Good day to you. I apologize for my absence as I'm teaching this lesson from a distance. I'm fighting some vertigo, so it's not a COVID-19 thing. It's just this constant dizziness that, I don't know, I think it's an inner ear thing. But it's keeping me from being here in class with you today. So, as you might expect, I hope you will look after your substitute teacher, whoever they are. um, give them give them good support as they are here for you, so we can stay open when with all this chaos going on. Also, it's more important than ever to tend to your protocols. Social distancing has never been more important, and being aware that this virus is making its rounds throughout the state. So just something to keep fresh in the front of your mind as we go forward. Okay, today's topic, the gas giants. This is Jupiter and Saturn. Let's go ahead and go through this one as a class, and then you'll have the rest of the period to work on your notebooks to continue your work forward as you press forward through page 17 if you're not quite there yet, and onward with the rest of chapter 1 if you are finished through page 17. All right, let's do this. Gas giants, here we go. Take a look at Jupiter, king of the planets, largest by far. And look at the auroras, the spectacular lightning storms that have been caught on actual video at the North Pole. Okay, a few prominent features. You see that it does also, like the Earth, like Mars, spin eastward. So if you could somehow be near its surface, its gas cloud surface, you would see the sun rise in the east and set in the west. It spins very rapidly. It's got huge storms going. It's got bands of different colors across its face, and it has just incredible lightning storms, which are the Jupiter equivalent of the aurora, where millions of volts of electricity are discharged in the upper atmosphere to balance out all that friction and all the potential in the clouds. Same basic concept as clouds on Earth generating lightning. If you were to take all the planets, all the other planets, Saturn all the way down to Mercury and all the moons, if you could somehow pour them into Jupiter, they would all fit in Jupiter with plenty of space left over. It's not like Saturn is just about the same size as Jupiter. Jupiter is just massively huge. It is its own little system. It has so many moons going around it. I think last count puts it at almost 70 or slightly more than 70. They keep finding more, so that number's always changing. Other prominent features, it's got that great red spot. Look right here next to the picture in the corner, right there. And the great red spot kind of faded in this image because it changes over time. It changes colors. Sometimes it's much more massive. Sometimes it's smaller. So it changes like a hurricane on Earth. And we've got a few of those going on in the world right now. Like a hurricane on Earth, it swells and it fades depending on the energy being added to it or if bits of it are dissipating. Another bright and beautiful picture of Jupiter. Look at the bright colors in this one compared to the previous one. That great red spot just jumps out. It's just very distinct. We know it's been there for several thousand years, but we don't know if it has always been a feature of Jupiter or if it will continue to be. It could be fading and it could vanish and something else could take its place, some other feature. We just don't know. They're watching it all the time as a matter of scientific interest. Moons of Jupiter are each unique and amazing and fascinating. We'll start with the innermost one. It's the one on the top of these four images. That's Io. Io is the most volcanically active piece of real estate in the whole solar system. Now, we have volcanoes here on Earth, and there are a few other volcanoes scattered throughout the solar system. None of them compare to Io. Io is dramatic, and it is so tortured in the core. Basically, it's inside the magnetosphere and the kind of the energy exchange in the close region up against Jupiter, and it's being wrenched and twisted in its core, and that keeps it really hot and constantly erupting these volcanoes that spew strong, volcanoes miles up off of its surface into space. Take a look at Europa. Europa, the flattest piece of real estate in the solar system. And it's just a big, huge ice skating rink with some dust that has settled on the surface of the ice. Ganymede is huge. It's the biggest moon in the entire solar system, much bigger than our own moon, but still, just still a moon. And then Callisto is another icy moon, similar to Ganymede, but not quite as big. Let's take a look, one of them, each one at a time. There's Io. Tidal forces ripping that planet up from the inside out. A map on Io would be pretty useless at just a matter of decades. The surface is constantly changing. That is a violent place, always being shredded. And in fact, when Voyager 1 passed by Jupiter and took pictures of the moons, they noticed this huge umbrella shape sticking hundreds of miles up off the top of the surface of Io, and they wondered what that was. And they said, "Is that a volcano? Are we witnessing an active volcano on another world?" Pretty intense moment for them when they witnessed that. Europa, on the other hand, peaceful, serene, at least on the surface. Flattest piece of real estate in the whole solar system. No mountains, no continents, nothing to speak of. It is entirely covered in ice. It's a ball of ice. But what is under that ice? Based on calculations of the size and soundings that see how deep the ice goes, and the possibility, the strong possibility that there's an ocean underneath the layer of ice that protects that ocean from the vacuum of space. That ocean, they predict, is double, at least, all the oceans on Earth. So take Pacific, Atlantic, the Northern Ocean, the Southern Ocean, right, the Arctic, and the Indian Ocean, lump them all together, double it. Now you have Europa's ocean underneath the surface. What swims in that ocean, I wonder? So, one strong place to go and look for life, Europa. Look at Ganymede, largest moon, icy brittle crust, and there's a saltwater ocean underneath they have recently discovered. It has its own magnetic field, so it has some kind of a metallic core that is spinning, and it has a North Pole, South Pole. It has some protection, but again, no atmosphere, unfortunately. Could we have a settlement there? Sure, but like any other body that we would have to make sure that it's environmentally sealed and contained. It would be inside an underground or a bubble, something to give the proper conditions to live on Ganymede. But it's huge, lots of real estate. It's far enough away from Jupiter that it's not so tortured the way that Io is. And take a look at Callisto, very similar to Ganymede, icy surface. This one has a thin little carbon dioxide atmosphere. We could potentially put a base on there as well. And it is beyond the magnetic field of Jupiter, and also not being tortured and twisted from the inside out. So it's relatively stable. That's Callisto. Now, the other moons of Jupiter are plentiful. There are dozens of them, like good 60, 65 more moons, much smaller little rocks that are in orbit in its moon plane of orbit. Okay. Now let's change gears. Saturn. They call it the jewel of the solar system. Okay. It is very low density. So if Jupiter was massive and strong and powerful, Saturn is light and fluffy, right? If you could somehow float Saturn in a vat of water big enough and somehow gravity still pulled down, if somehow all those things, it would float on the top. The Earth and Mercury would sink right to the bottom. They're denser than water. But Saturn, on the other hand, would just float. And those rings, right? The gas cloud tops of Saturn are impressive and serene and beautiful to look at. It's the rings that really grab our attention. Super thin, very wide. They've lettered the rings A, B, C, D, E, F, and so on. And because of observations made just in our lifetimes since the 1970s, basically, They predict that in a matter of a few 100 million years, those rings will fade and be gone as the chunks of ice that make them bump into each other and start to disintegrate, or the tidal forces of Saturn either compact them or allow them to crash into the planet's surface. So in the relatively near future of the solar system, Saturn's rings will fade and eventually be gone. That's the prediction now, anyway. I mean, we won't be around to see it, but it kind of makes us appreciate that we have the rings to even look at this time. Beautiful planet. Let's take a look at one feature in particular, and then I'll show you one moon in particular. Look at the North Pole. When they finally flew Cassini, the probe, up over the top of the North Pole, they noticed this very strange hexagon shape. They think it's because of resonance of the clouds, and it's almost like vibrating at a certain frequency that creates this very regular hexagon. You can see in the animation the wind blowing around the North Pole as the planet itself turns, and we don't know why. Why is there a hexagon shape? Lots of different ideas out there. For now, they're still working on it, trying to figure out what makes Saturn have this very strange feature on its North Pole. Let's take a look at the moon. Titan. Titan is a fascinating place. Second largest moon in the solar system. Thick atmosphere of Saturn. Methane lakes and rocky shores. This image was from the Huygens little lander. It's about the size that three of us could pick it up. It's a small little lander that gently landed in the rocky part, took these pictures, sent them up to its mothership Cassini, that beamed the images back to Earth. Look at that. Okay, I'm going to move my little image here out of the way so you guys can see. Look at that. That's the surface of a moon going around Saturn. Strong potential for human settlement. It's just so far away. It would take us years in a very fast-moving spaceship to get there. But it has methane. We'd use that as a fuel source. We know how to take methane and other elements and chemically alter them, make water or hydrogen. Let me wake up the lights here in the room. Sorry, hang on one second. Okay, there we go. Sometimes my lights time out here in the classroom. All right, so the probe took pictures, sent them back, gave us a lot of amazing insight into this fascinating place, Saturn's moon Titan. Okay, moving on. Look at another moon of Saturn. This is Enceladus. Enceladus is a small, unregarded, icy moon, similar to the others like Europa and Ganymede and Callisto around Jupiter, except this one is active. It's speaking, it's doing things. At the South Pole, hundreds of these cryovolcanoes. Now, you know about a volcano on Earth. It spews lava and hot magma, and you get near it and you get cooked. This is the opposite. This is like a slushy volcano. Like you go to 7-Eleven or Texaco or whatever, you get a slushy, right? It's one of those type consistencies that's blasting out into space, which means under the ice there has to be heat and warmth. And look at this thermal image under the ice. They found strips and stripes of heat underneath. That is fascinating to me because we know it's there and we just can't explain why there's these heat sources underneath the South Pole of Enceladus and what's going on with those cryovolcanoes. Imagine fish swimming under the surface in whatever warm ocean is there, right? And they get caught in a current and they get blasted out through these cryovolcanoes into space. Strong possibility to go and look in those geysers to see if there's any organic material being ejected from the South Pole of that moon. Fascinating possibilities. There's already plans to go back and take a closer look at Enceladus. The whole planet is covered in fresh, clean ice delivered to it as falling snow and ice crystals from all those geysers and cryovolcanoes on the South Pole. Pretty fascinating place. All right. Now, Saturn from the ground, we're going to zoom back a little bit. This is one of our really best images we can get of Saturn from a really good quality telescope. Okay. And then we sent Cassini. Take a look at what Cassini sent us back with the sun behind it. Look at that. This is an untouched, unmanipulated photo. That's what Cassini saw when it was zipping around Saturn for a dozen or more years. Incredible. Just makes us appreciate how beautiful Saturn really is. Okay, let's change to looking at your book. Okay, so you're building your profiles on Jupiter. Same type of profile you've seen for all the other planets you've already built. Now we're in the second part of chapter 1. Jupiter, fill in those good sentences underneath, make a good picture of Jupiter. Like always, trace your circles, please. And that way, you give the planet, give nature its due, because it is beautiful. It's not lumpy like a potato or anything. So don't freehand your planets. Use something you can trace. Find something at home to trace. And then look at Saturn. Take a look at that one. However you choose to do Saturn, you can make it bigger and the rings are going off the page. I know what you're drawing. So make it your own version of Saturn as you wish. Okay. All right. So there's Saturn. When you're finished with those two and you feel like pressing on ahead to Uranus, be my guest. Note that Uranus has a vertical ring system. Like the planet has been tilted way over on its side. And then we've got Neptune as well, the great dark spot, a storm, cold, frigid, fastest clouds in the solar system, fastest wind, I should say, in the solar system is Neptune. Okay, and that's it. That concludes my part of our lesson today. Thank you for your attention. Keep supporting our substitute today. I hope to be back by Thursday. I got to get my ears checked out and see what it is that's making me have this vertigo. Again, I apologize for my absence. And I wish you every bit of joy as you discover and adventure into the cosmos with building your book of astronomy. Have fun with the journey. And when we're back in class again, I'll make my way around the room and get you credit for your first chapter check, chapter 1A through page 17. Thank you, and I appreciate it. And we'll talk some more soon.